So the first class might have given you quite a nice experience, and you must have revised certain bit that had been discussed. Well, as a teacher, it always becomes an interesting and important habit just to take the follow-up what you have done. So I this time assume that you have gone through all those discussion and hope everything is fine, everything is comfortable, and you are doing in a wonderful state of health, isolation, insulation, accepting the norms, and of course helping India to go and to gain a better health condition and the desired output. All right, so as a citizen, all of us must do that. We must comply to the regulation, and every one of us must come as a corona winner. Do you know one thing, that we have something called as corona discharged in physics? Perhaps you must have learned about that. Class 12th, electrostatics. You must be remembering that. If you have a sharp edge conductor, then the charge density there becomes higher and it tends to leak off when the breakdown strength is exceeded. Okay, just the way to relate wherever you get corresponding thing. Let's see now, let's begin. You know what we had talked yesterday. एक बार मैं slight recap कर देता हूँ. We talked about precision, we talked about accuracy, and precision is something directly related to the least count of the device. Lesser is the least count, more is the precision. And how do we recognize a device is precise? Just by observing the number of digits after decimal. Jitna zyada digits after decimal hai, the reading would be more and more precise. That was what we did. Then we talked about accuracy in a larger aspect. If you are measuring certain value, like you are measuring a fixed value, for example gravity, then any value closer to that will be more accurate. And then we talked about the least count. We saw quite interesting thing. We saw any measuring device has a limitation. Like if you have a millimeter scale, then you cannot write it as 2.1 millimeter. क्योंकि millimeter scale है तो आपको लिखना millimeter में ही होगा. Either you call it as 2 millimeter or you call it as 3 millimeter, that's fine. But you cannot call it as 2.4 millimeter. Generally we sort of tend to approximate, but that is not allowed. जैसे जिस रीडिंग को लेना है, मान लेते वो 2 और 3 मिलीमीटर के बीच में है. So in that case we tend to write it as 2.5, but you know that is not allowed. And then we talked about significant figure, and of course one thing we had seen, that if you want to talk about the least count error, then in that case the one having higher relative error will be more less accurate and more erroneous. So that's equivalently the same. Lesser relative error, more accurate. And then we talked about significant figures, rounding off. We saw that there is certain rules associated with counting of significant figures, and we saw all those given situation. All right, now another thing that we'll be talking about is about a device, and that device is called as the Vernier Caliper. So let us try to see, and we will confine ourselves only into the syllabus prescribed by NEET. So as far as NEET syllabus is concerned, we will be focusing on the least count of the device. That is what we'll be doing. And you know, as one example, I will show you how to find the measurement as well. Although if you see the past year questions and the trend, the question that you get from Vernier Caliper and the screw gauge is regarding the least count of the device. तो हम least count कैसे निकालते हैं Vernier Caliper और screw gauge का? We will just focus on that point. By the way, one small excuse I need to seek rather, because my sense of drawing is very, very poor. Well, if it was a multimedia board that we do have, then, you know, the figure comes with a click. But this time, you know, since I'm taking the class from home, so this is the board that I have, and I'll just try to make the figure. You just assume it is a Vernier Caliper. That generally happens. I'll just share you that I'm so poor in the sense of drawing that I remember my junior classes that if I make an, so to say, something like this, I think now I've developed a bit. So this is a mango. Summer season is coming. But you know, the sense was so poor that after making a mango, I had to write that this is a mango. Then and only the teacher could understand and could realize that yes, the figure drawn by this boy is mango. That was the sense. Otherwise, I'll tell you, I was quite interested in biology and physiology, but the drawing sense was so weak that I had to opt for the you know, non-med background. That is what it says. Okay, now let's see. We'll talk about the device, and that device is the Vernier Caliper. First of all, try to understand, if you have a regular scale, what do I talk? A regular scale or a ruler, you call, the one that you use in your geometry class, then that particular scale has a least count of 1 millimeter. That is the least count it has. So 1 millimeter, that means 0.001 meter. That is the least count of a regular scale. And you know, if you have a scale, just try to realize this fact. Suppose you have a scale, then you have those millimeter marking. An unaided eye cannot resolve a distance lesser than a millimeter. Generally, well, if you have a super strength of your eye, you may distinguish the marking between 1 millimeter. But in these cases, we need to take an average. So on an average, considering all the age group, अगर least count 1 millimeter से कम है, so identifying that least count is very difficult. So with the help of a scale, what you can do is that you can only go for a measurement having a least count of a millimeter. But then people want least count lesser than a millimeter. So here comes a very clever arrangement, and that arrangement is called as the Vernier Caliper. So we will be talking about this Vernier Caliper, and the Vernier Caliper, generally the least count ranges in 0.1 millimeter, or if you say in meter, that will be 10 raised to the power minus 4 meter. I'm simply talking about a general statistic. Well, if someone wants to make a better than this, they can go, but by and large, when we specify the range of the least count of Vernier Caliper is 0.1 millimeter, the order, you may say in that way. Now, how does a Vernier Caliper look like? Now, this is the big challenge I'll be facing, but still, let me try with that. I don't know how successful will I become. This one has gone wonderfully. Okay, so there's a scale, and that scale is called as the, you know, the main scale. So this is what you call as the main scale. And the main scale has the least count of a millimeter. Generally, like a regular ruler that you use, that can be treated as a main scale. And this part is fixed to the main scale, and this is called as the jaw of the main scale. All right, now together with this main scale, there is another smaller scale, and that is called as Vernier Scale. And that Vernier Scale can slide right here. So that's a slidable scale. And let me try to draw how does it look like. So something like this. Okay, so here is that vernier scale. You could see this gap needs to be neglected. This is nothing like that. It's not that anything will be fixed here. And here, you see, this is the case. And this is the vernier scale. And you may call this as the jaw of the vernier scale. That's fine. Now, just a schematic representation. You know, physics does not give me pressure. Physics I can handle very wonderfully. But when it comes to drawing, you must have realized. Let's say, nevertheless, talking about the schematic representation, this is the vernier scale, and you may slide the vernier scale here. That can be slid along this. And here what happens is, right now, there is nothing to be measured. Anything that you want to measure, you know, you slide it here and you fix that object here. Let me show a typical representation that when something is being measured. So this is the main scale here, and the vernier scale is there, and the vernier scale can be slid, and that object whose length you wanted to measure, you will be fixing up between the jaws. So this shaded one, okay, this one is the length that you want to measure. Generally we keep small lengths to be measured because the purpose of vernier caliper is you want to measure smaller length with a high degree of precision. तो ऐसे सिचुएशन में जिस भी ऑब्जेक्ट का लेंथ आपने मेजर करना है, आप उस ऑब्जेक्ट को इन दो स्केल्स के बीच में tightly, you need to fix it very tightly. And then the reading would be taken. We'll talk about that. But here, the first thing is say, now, this is the figure which will help you to calculate the least count of vernier caliper. Now, here is the case, say. Let's begin with this. The zero of main is here. The first main, second main, third main, it goes in this way. So there is the first terminology we have, and that terminology is called as the main scale division. We call that as the main scale division. By the way, guys, just focus on one thing. This is the main scale, this is the vernier scale, and the combination of these two will be called as the vernier caliper. So just be very attentive with this. Saying vernier scale and saying vernier caliper is entirely different thing. Now let's see, this is the main scale division. So this is called as the main scale division, and 1 MSD, that's also called as the main scale division. Chennai Super Kings fan, this is not your captain Mahendra Singh Dhoni. So this is simply main scale division. Now let's say 1 main scale division, generally it's the least count of the main scale. That's very fine. So there is another scale, and that is called as the vernier scale division. That's called as the vernier scale division, and that will be called as the VSD. Okay, now let's see, where does VSD stand? And you need to concentrate on this figure. Like here, the initial one is this. 0 of the vernier is here. And for a device without any error, when the jaws are touching, you know, the 0 of main and 0 of vernier would be exactly coinciding. So that happens if the device does not have any defect. That error is called as the 0 error, but we'll not be talking about that. Just to give you an idea, when the jaws are touching, the zeros of both the scales, they have to coincide and they have to match at one given point. And now here lies the most important idea, the most important thought process, physiology of the device. and that is, now just have a look in this, the first Vernier scale division is slightly lesser than the main scale division, and that is knowingly kept, it's not by any defect. तो इस चीज़ को हम जानबूझ के रखते हैं, knowingly kept, that one Vernier scale division would be slightly less, थोड़ा सा कम than the main scale division. So typically if you say a main scale division is 1 millimeter, then a Vernier scale division could be 0.9 millimeter or it could be 0.8 millimeter. Generally lesser than that is not kept, because you should understand the very purpose of a Vernier caliper was that a regular scale 1 millimeter is readable, but lesser than 1 millimeter it tends to be difficult. So if we start keeping the Vernier scale around 0.6, 0.5, then you know the whole purpose of designing this device would be violated. So generally 0.9 millimeter is the standard one, but as a numerical you may get anything. You may get 0.8, that's fine. Now let's say the Vernier scale division, one thing is kept, this is very fact, that the main scale division is greater, and let's use the word slightly. The main scale division is slightly greater than the Vernier scale division, and that is knowingly kept. That is the main cleverness in this device. Now let's say, just think in this way, that the first mark of main and the first mark of Vernier, the Vernier lagged behind by a certain distance. Now the lag in the second would further increase, isn't it? Lag in the third would further increase, because the Vernier scale division is slightly lesser than the main. So as you increase with the mark, the difference between the Vernier scale and the main scale will keep on increasing. Like in the first, there was a bit of difference. Let's take it mathematically. Just imagine the main scale is 1 millimeter and Vernier is 0.9 millimeter, say for example. So in the first mark, the difference would be 0.1. In the second, the difference will be 0.2. So in that way, the difference keeps on increasing. So the difference increases, increases, increases. Then you suddenly find that at a certain point, the main scale would exactly match with the Vernier scale. That happens. So as you proceed further, further, the main scale again will come to match with the Vernier scale. But this time, if this is 10 Vernier scale division, then that would have been 9 main scale division. It's something like this, say. Just imagine, like here is a racing track and two cars, the car faster and the car slower, okay? F is the faster car, S is the slower car. So they start racing. So with the gun, boom, they start. As they start, after some time, you would find the faster one would be here and the slower one would be here, isn't it? And after some time, you see the faster one or the slower one would have reached here and the faster one would have reached here. So this is F1, S1, F2, S2 at second instant of observation. The third instant of observation, that would be the situation. Soon a time will come, the gap starts increasing. Again, the faster and slower would be together. And this time, the faster would have completed one more lap, one more round than the slower, isn't it? So in the similar manner, the gap increases. A time will come when the main and Vernier would again match. And by this time, the Vernier division would have one more mark than the main. Like if it is 12th vernier, then this would be 11th main. If it is 13th vernier, it would be 12th main, say for example. Now you can just verify it mathematically as well. Like let's say, just to give you a mathematical example, for example, if one main scale division, say that is 1 millimeter, and one vernier scale division is 0.9 millimeter, say in that case, now what would happen? Just think, what would be the 10 division of vernier? That will be 9 millimeter. And what would be the 9 division of main? That would be 9 millimeter. So that is how it comes. Alright, so now we have understood this particular fact, and what we'll see is that after we get this thing, now we are at the point to compute the least count of the device. So here the formula of the least count comes in this way. The least count of Vernier Caliper. Remember, the entire arrangement is called as the Vernier Caliper. This is the Vernier Scale, this is the main scale. So the entire least count of the Vernier Caliper is defined as 1 MSD minus 1 VSD. 1 main scale division minus of 1 Vernier scale division. So this is how we compute the least count of Vernier Caliper. So that is the underlying formula for the least count of Vernier Caliper, which is 1 main scale division minus 1 Vernier scale division. So this is quite an important formula. You need to memorize this. Now let's say for NEET, just be assured that the question corresponding to computation of least count is the one that will be requiring. Now let's try to make another formula. Let n VSD is equal to n minus 1 MSD. Now here it says let. It's not that n VSD will always be equal to n minus 1 MSD. It can also be n VSD is n minus 2 MSD. I'll show it by example. So right now we saw, therefore I have said example. 1 MSD is 1 millimeter, 1 VSD is 0.9 millimeter. That's the general example. So let's just focus on this. What happened? The 10th vernier division matched with the 9 main scale division. So what would be the value of n? That will be 10. You would get the question that 10 vernier scale matches with 9 main scale. So those sort of question. So what would be n? That will be 10. So realize n is that mark of vernier which coincides with the main. जैसे कि अगर 10th vernier division 9th के साथ match हो रहा है, so n will be 10. All right. Now let's say you will come up with this. So 1 VSD will be equals to n minus 1 by n MSD. So that's fine. And now comes the formula for the least count. That will be, let's say, 1 MSD minus 1 VSD. Just putting that n minus 1 by n MSD. I'm just replacing the value of VSD from here. A little bit of calculation, you get least count as 1 by n MSD. You may take it as a formula, but remember guys, this formula has a validity, and that validity is n VSD should be equals to n minus 1 MSD. In that case, this formula would be valid. Now, many times, examiner is quite clever. People see that many people simply memorize this expression and they come up with the preparation just by memorizing this. Then they suddenly make a slight twist in the story. So what would be that twist, we'll see. But as of now, let's do a question here, and that question is for you. The question is something like this. Just be ready that in a Vernier Caliper, this has been given, a MSD is 1 millimeter, that's given, and 10th Vernier scale matches with 9 main scale. Now you need to calculate the least count of the Vernier Caliper. So that's the first question to you. Waiting for the answer. I need the answer in millimeter. Please do that. I'll be waiting answer from people like Arvind, Benji, Vidushi, Pratik, Devank, Arvind, Shri Krishna. All right, people like this, Divyanshi, Kritika, because yesterday you had come up Rajvardhan. Yes. So Shubham, Pratik, Devank, Shri Krishna, Rajvardhan, as I say the name, Pankaj, Aishwarya, all have come up with an answer of 0.1 millimeter. And that's absolutely right. Absolutely right. Wonderful people. Because it says a MST is 1 millimeter and 10th Vernier scale matches with 9 main scale. So here the least count of the device would be 1 by n MST. And the least count now will come as 1 MST is 1 millimeter and n would be 10. Because 10 Vernier scale matches with the main scale, and 1 by 10, that is 0.1 millimeter. All right, now I'll just show you different way of, and yes, I got Mizol, Sunidhi, Arvind, Aman, Benji, Jay, Vidushi, great people. Okay, now let's see. This was about the reading in millimeter, just a repackaging. Now this may be also called as 10 raised to the power minus 4 meter, isn't it? Or this may be called as the 100 micrometer, because you multiply meter by 10 raised to the power 6. That's going to give you the value in micrometer. Any form of repackaging, that is not an issue. So you just see here, simply main scale had a least count of a millimeter, all right, and the Vernier scale had a least count of 0.9 millimeter, but the difference is 0.1 millimeter. By the way, before we go to the next segment, you just tell me, how was the figure? Is it good? All right, you need to say it in the scale of 1 to 5. You need to write that. I need that answer as well. Okay. Fine. Now let's move to the other case. I was saying that this formula is not a general formula. This is not a general formula. The general formula is this. The least count is 1 main scale division minus 1 Vernier scale division. So here, what I'll get is that if this condition is valid, then you get this. Now let me make a slight change and I'll just help you with the data. Let us say, just think in this way. Suppose 1 main scale division is 1 millimeter, say for example, and 1 Vernier scale division, say, is 0.8 millimeter. So the gap is further increased. Not much, but further increased. Now in this case, you can see 10 Vernier scale would be 8 millimeter, and to have 8 millimeter you go only 8 main scale, because from this figure now you could realize, guys, that 10 Vernier scale will be equals to 8 main scale. In other words, NVS will be equals to n minus 2 ms. So that is what you need to understand. All right. So this is how you get 10 Vernier scale division is 8. So if you put 10 as n, this will be minus of 2. So n minus 2 main scale. Now let's come here. Suppose if this is the situation, let's try to solve it. If that's the case, if n VST is equal to n minus 2 MST, even that can happen. Now let's try to see how much will be the least count. Why not you people try? Calculate the least count, like that will be something like a formula. N VST, that was 1 by n. Try this, please try. That's great. Thank you people for all your response, and I'm touched. Benji 10, Pratik 10 plus, Divyansi 10, and an honest answer from Pankaj Rana 4. That's great. Shri Krishna, Ashorya, Rajvardhan. Okay, now here I got the answer. Kapinjal 0.2, Ashorya 0.2, not the figure one, the least count. 0.2 millimeter, Divyanshi, and Kanika, Rajvardhan, Aryan Thakur, great. Mohammed, Aman, that's great. Eshita, that's great. Okay, now let's see. Benji, you have been given quite nice answers, so that's great. Now let's see. N VST is n minus 2 MST, so you will get 1 VST is equal to n minus 2 by n MST. So that will be least count of the device is 1 MST minus 1 VST. So this is going to be as 2 by n MST. If you prefer, you may memorize this, or if you do not want to prefer, just keep one thing in mind. This is the general formula, and that now varies from case to case. That's very encouraging. Yeah, Jaswant has also come up. Archismita Day, that's also right. So we have done about computing the least count of Vernier Caliper. That's how it goes. Now, let me just focus only up to this. Let me just focus in the NEET syllabus and the time that we have. It's a limited time course. So I'll just touch on those areas which are prime, which are most important. So yes, we have people from all over the globe, and lot many people from Earth are watching it, and that's a nice thing. As I had been saying, that this is quite a nice experience, a new learning experience. So let's now go to the next device, and that's called as the screw gauge. And let's see how does typically a screw gauge looks like. We call it as the screw gauge, or many times we also call it as the micrometer screw gauge. That's all equivalently same. Why do we give the word micrometer often? Is all because the least count generally comes in the range of a micrometer or maybe 10 micrometer. That's a reason why. But yes, the precise name is the screw gauge. And a screw gauge generally is used to measure the diameter of small spheres. You may say that it is used to measure the diameter of small spheres or maybe it's used to measure the diameter of, thin wire. Like you have that small electricity wire, बिजली की तार, one strand आप निकालो, only one strand, it's very very thin. और अगर उस strand की diameter calculate करना है, you want to measure the diameter of that strand, तो उस given situation में we come up with better device, more precise device, least count device, because lesser is the least count, more is the precision, and that is the screw gauge. Now let's see, how does a screw gauge look like? A rough idea. So a screw gauge is something like this. Let me make it a bit thicker so that you can understand it. So this is how the screw gauge looks like typically, and here let me just go step by step. Okay, the first thing is, say here is a handle, and with the help of this handle you can lock it or you can unlock it, like just a right hand screw. By the right hand, if I rotate in this way, just see how you open up a bottle lid. So by the right hand, if you rotate in this way, the lid comes up, and if you rotate in this way, the lid goes down. The idea is very similar. So here, just to give you a view, you can do that. All biology people are good in imagination. So this is how it comes. If this is the direction of arrow, say for example this, so as I rotate in this way, this will go in this direction and the screw would get closed. So this gap is necessary, and here we fix that object whose diameter we are intending to measure right here. That's the case. We fix up that object whose diameter we really want to measure. All right. Now let's see what happens is, there is another scale here, but before that, here comes, there is a main scale. This is the main scale that's there, and it comes something like this. If I show the main scale, now I'll just show the main scale, this one. The main scale is something like this. This, the main scale comes here. And it's also called as the linear scale, or it is also called as the main scale. It's all equivalent. So you may call this as the linear scale, or you may call it as the main scale. It's all equivalent. Call it as the linear scale, call it as the main scale, that doesn't matter. And you know what? This distance, the separation between the two marks of a main scale, you call it as the main scale division. And that main scale division is also called as a pitch of the screw. So one main scale division is also called as the pitch of the screw. Like if you have a screw, you have threads, isn't it? So the distance between the immediate spiral thread, that's called as the pitch. All right, so this is the first thing that you get. And here is the circular scale right here. So here is the circular scale, and in fact, the rotating part that is connected with this. And the circular scale is this. So here is the circular scale. And there are markings in the circular scale. So there is a proper fitment. This gadget is very wonderfully fitted, and let us see how it is fitted. The fitment is in this way. As you start rotating this, the circular scale would rotate. But as you start rotating, the black one would also start coming in this direction. That's how it comes. And together with this black one, even this thing would also come here. So as you start rotating, this circular scale starts going in this direction, what we generally call as the screw is getting opened up as you start rotating. And if you go and rotate in opposite direction, then the screw would be closing. So if I do in this way, it goes in this direction. And then the final mechanical, the final engineering of the device. Now here, listen it very attentively. The engineering of the device is in one complete revolution. In one complete revolution, either it opens or closes depending upon the clockwise or anti-clockwise sense. And in one complete revolution, this circular scale, would come this side, and the linear distance it travels is exactly equal to one main scale division. Let me explain it in other words. Like when you open up a bottle, it starts coming up. So in one revolution, it exactly comes equal to one thread. That's always maintained. And you need not worry about this. So this is the job of an engineer. So the manufacturing is done in such a way that in one revolution, it exactly comes up by one thread. Similarly, in one revolution, it exactly comes by one main scale. So this is how we come, or the pitch is also defined. Alternatively, we define pitch as the forward distance traveled, forward distance traveled in one full revolution. So if you go for one complete revolution, one full revolution, the distance it travels, either forward or backward. The forward means, I'm just talking in the context of increasing, decreasing, that would be backward. So you may say linear, that's all equivalent. That is exactly measured or kept as one main scale. That's the idea. So hope this thing is clear. Now let's see. Anjali, I'll certainly do. Please do not worry. Now here, the case is, what comes is that, Anjali, you have come up with the request of Vernier Caliper. Meanwhile, let me do it. People would get engaged in the numerical. I'll do that for you. Just hold patience. I'll do it. So now, this is the case, say. What you find is, the least count of a screw gauge is defined as 1 MSD, or you may also call it as the pitch, divided by the number of circular scale division. CSD is called as the circular scale division. That's how it comes. So least count 1 MSD, 1 pitch, divided by the number of circular scale division. So let's go with the question. Let's say that 1 MSD, we're going with an example, is 1 millimeter, let's say. And the number of circular scale division is 100. Just listen to the question. I need the least count in micrometer. This is what I'll be requiring. So please do that. Meanwhile, Anjali, please see. What we do in Vernier Caliper is, just make it simple. I'll condense it. That when 0, 0 matches here, there is a lag because vernier division is kept lesser than main scale division. So by this time, it can happen that 10 vernier division will match with 9 main division. Okay, so now just make it simple. If 10 vernier division matches with 9 main scale division, Anjali, in that case, least count is 1 MST minus 1 VST. That's a general formula. So that will be 1 MST minus, 1 MST. If 10 VST is 9 MST, 1 VST will be 9 by 10 MST. So all you need to do, Anjali, if you want to make it simple, just memorize this expression. Least count is this much. And one main scale division is 1 millimeter. You can easily calculate. Like in this question, if 10 VST is 8 MST, then again least count is this. This formula is always valid. So now what would be? 1 VST will be 8 by 10 MST, because the condition is 10 VST is 8 MST. So if you want to take it simple in a light version, this is the formula and just you make the calculation. All right. Now I have lot many answers. Shaurya, Kanika, Shubham, Shrey, Anuradha, Tushar, Shri Krishna, Amal, Pratik, Pankhudi, Vidusi, Aishwarya and Devanik. You say that the option is 10 micrometer. That's perfectly fine. Anvesha Mishra has said that how is the calculation done? Well, Anvesha, there is a typical science. It is not very random that we call it, but we would be hiding that. We'll start from the formula, but it is the minimum distance and there is science behind it. But considering the examination we are preparing for and considering the time we have, I'll just focus on the examination part. And I would recommend and request for you to do also that, because you can exactly focus on the target area. Pankaj, Ashita, Archismita, Divyanshi, Divya, Jaswant and lot many. Prerna, Vignesh, Pankaj, that's great. 10 micron. So this is how it comes. Least count in micrometer, if you see, that is 1 main scale division by number of circular scale division, that is 100, and 1 main scale is 1 millimeter divided by 100. So 0.01 millimeter, you convert it into micrometer, so that's going to be 10 micrometer. So that was about computing the least count of vernier caliper and screw gauge. Now we'll go to the next part, and that is called as error propagation. All right, people, now let's see, what does that error propagation mean? Now again here, let me tell you the strategy. In this strategy, we would not again be going on the derivation of this. We would list up the formula. Of course, we'll understand the meaning of those formula and we'll directly see the numerical application of that. But first let me tell you, what does that error propagation mean? People, there are two types of values. One value is called as the measured value and another value is called as the calculated value. So we have two sorts of values. One is called as the measured value and the other value that I have is called as the calculated value. Now what's the difference between them? Measured, that means you have a scale, you have a device, you measure it. Say for example, you are measuring the length, you're measuring the width, maybe by using vernier caliper, maybe by using screw gauge. आपने वो length और width को measure किया. Now what about calculated value? The calculated value means you are not using device to measure. All you are doing is that, like you say area is L multiplied by B. Now let's see. Let's try to understand the difference. This is measured, this is calculated and this is measured. And every measured value does have a certain amount of error. That's known, isn't it? You can do nothing about that. The error can be minimized, but the error cannot be made zero. So that's a fact that we know. Now let's say if this has error, when I multiply these two erroneous value, we call that as erroneous value, the value having error. We would be interested to learn how would that error appear when these two erroneous values are multiplied, or how would that error reflect when these two values are divided, added, subtracted, anything. So let's try to see that. This is the main concept, but as I said, we will not be able to do the derivation. We will be doing the formula. So before that, if I say that if you have any value L plus minus delta L, what do we call? This has the absolute error. We did it yesterday. Delta L by L is the relative or fractional error, and multiply that by 100%, that's going to be the percentage error. That was what we did. So let's say first we'll talk about addition. Well, there is derivation of whatever we are doing it. We do it in a long-term program, but since here our target is to exactly hit the nucleus, so we'll just talk about the formula and the application of that. Suppose I have one quantity x, so x will have a corresponding error which is delta x. Let me make it clear. Okay, delta x. You have another y, and y will have its own set of error, that is delta y. Now let's define z is equal to x plus y. So you are adding two quantities. So when you add two quantities, z equals to x plus y, then you come up with this. The individual error on that, the individual absolute error, that is also added. So this part you'll have to take as a formula, that whenever two quantities are added, the absolute error of these two individual quantities, the absolute errors are also added. So that was about addition. Now let's go with subtraction, and after that we'll do a numerical for addition, subtraction, let's see. Similarly, x plus minus delta x, y plus minus delta y. So the quantity is subtracted, x minus y, but the absolute error in both, they are added, delta x plus delta y. So this is how it goes. The quantity is subtracted, but remember guys, the absolute error is added. So this is not a printing error or an absent-minded error. So just be careful. I repeat for the last time, the quantity are subtracted and the absolute errors, they are added. As I've said that we will not be talking about the derivation of this. Now let's see with a question. Say you have a cylinder, and let me give some dimension of this cylinder, and this cylinder has outer radius as 10.00 plus minus 0.01 centimeter is the outer radius. 10 centimeter is the outer radius, but there is always an uncertainty in the value of that, and that is plus minus 0.1. The inner radius, say, is 8.00 plus minus 0.01 centimeter. So that's a case. Now please calculate the thickness within error limit. So that is what you need to do. You need to calculate the thickness of that cylinder within error limit. That means you need to report the answer thickness plus minus in that given pattern. Go ahead, people. Yes, options have started rolling in. 2 plus minus 0.2. Shubham Rathi, Shaurya Mitra, that's great. Charumati, that's great. Some more options rolling in. Yashwant, Subhash, Kanika, Kapinjal, Vignesh, Amal, Shreya. Perfect, people. So all, meanwhile others would also be coming. So let me deal with this. Okay, so here is how we do that. By definition, we know when it comes to the definition of thickness, thickness is outer radius minus of inner radius, right? And quantities are subtracted, so that will be 2.00, but the uncertainty would be added, so plus minus 0.02 centimeter. This is how we report the thickness. That's great, and lots of other options pouring in. Now let's see. In the same question, suppose if the question says to calculate the fractional error in thickness, if I want to calculate the fractional error in thickness, so that fractional error in thickness, of course, by formula would be delta T by T, and just plugging it plus minus 0.02 divided by 2.00. So that's a fractional error, and you get that as plus minus 0.01. That will be the fractional error. All right, and if at all the question says to calculate the percentage error, so the percentage error of course would be equals to plus minus 1%, because we are multiplying it by 100. That is how the question goes, a straightforward one, but these are all very probable questions. Okay, now after this has been done, this was about addition, this was about subtraction. But remember, in addition subtraction, by default means formula आपको क्या दे रहा है? Formula आपको absolute error दे रहा है, और अगर आपको relative error निकालना है, you'll just do some extra calculation. So remember the pattern, that by default you get the, by formula you get the absolute error, and you want to calculate the relative error, you divide it correspondingly. All right, so now that's great. Ashmeet and Shaurya, they have come up with 1% answer. Great, bravo. Now let's go with another case. Now the next case is when the quantities are multiplied. So let's say if the quantities are multiplied, then Z will be equals to X multiplied by Y. That's how we multiply it, isn't it? And the error is delta Z by Z will be plus minus delta X by X plus delta Y by Y. So people realize one thing, just look at how the formula is evolving. When you are multiplying two quantities, it is not the absolute error which is added. What is added is the fractional error. But this does not mean that I cannot calculate the absolute error. Certainly I can do. And that's a simple matter of calculation. All I need to do is that take this z, this side, multiply there, you're going to get the absolute error, isn't it? So just realize, like in the case of subtraction, the formula gave us the absolute error, and we had to work out a bit to calculate fractional error. So in multiplication, the case scenario is slightly different. In multiplication, what we do is that the formula gives us the fractional error. If you want to calculate the absolute error, just take z this side, you'll get it there. Together now, let's go for division as well. So if I want to calculate the division, that's how it goes. Z equals to x by y, and you get delta z by z is plus minus delta x by x plus of delta y by y. One thing is sure, perhaps you must have certainly noted that when it comes to multiplication and division, the pattern of formula is same. When it comes to addition and subtraction, the pattern of formula lies to be same. Let's do a numerical for multiplication or division 1, shall we? All right, people, so here is the case. Let us say, now this time I'll be a bit tricky. For example, it says that the mass of a body is, let's say, 100.00 gram. Nothing has been said about the error. And you must be knowing that when nothing is said, that means that's plus minus 0.01. And let's say that the volume has been given as how much? All right, let's say 10.00 cc. That's what it has been given. All right, now the first thing is that we need to calculate the, let's say, report density. So when you have to report density, you need to report the density as how? If you report, that will be rho plus minus delta rho. In this form, you're going to report it. So density, the normal representation, we do it by rho. Please do it. Shaurya Mitra says 10 plus minus 0.011. I'll just check out. Aakash student says 10.00. Well, Aakash student, the density is 10.00, but you need to do the delta rho as well. Divyam, Pratik, Pankaj Rana says that. Amal, that's great. Shaurya, Ashita, Shri Krishna, Ashita, yes, you have come up with the correct option. That's great, people. And it's very, very encouraging as a teacher. You don't know that how beautiful environment in New Delhi is going on. My students are giving nice answer. The participation level is going high. So just remember, people around the globe, we are going with a very wonderful thing here. The morning is going very creative. Calculating error, though. All right, let's see. I need to do the density by formula. Density is mass per unit volume. So I get here, it's a form of division. Delta rho by rho is delta m by m plus delta v by v. And here comes plus minus, that's what we can do it. But my purpose was to calculate the delta rho. So let's say step by step. Delta m 0.01 by 100.00, all right? And delta v, that is 0.01 by 10.00 multiplied by density, because I'm calculating delta rho. So rho would go there. And if you calculate that density part, that density will be 10.00. Mass per unit volume, the exact quantity. And let's see further what's going to happen. This 10 will be 10 here, so that is 0.001 plus 0.01. That's what I got it. And this is going to be 0.011. That's how it goes. But you know, the answer, because there are 2 digits after decimal, so all you need to do is that you go with a slight rounding off, 0.01. That's the, you know, absolute error in the density. So the density is going to be represented as 10.00 mass per unit volume plus minus 0.01, and yes, the unit would be gram per cc. That is how it comes. So yes, like I got that answer there. Kapinjal Sharma, Shubham Rathi, perfect. All you need to do is that you just need to, you know, eliminate the final one, but that you can do certainly, because in the question you get options and you can easily figure out. That's great. And many people, because the list has gone so long that I'm not able to say all the name, but that is giving me a confidence that people are really doing this, and that's very much essential. That was about multiplication, that was about division, and the final thing comes when things are in power. Let's see. So if you have things in power, like say x is a quantity, a raised to the power m, b raised to the power n divided by c raised to the power p. This parameter is more general. This would include both the multiplication as well as division. Just see, if the denominator is not there and m and n are 1, that will be a multiplication. And if one thing is not there, say b is not there, and m and p is 1 each, that will be division. So this is kind of more general. And here the underlying formula for this comes, people, delta x by x is plus or minus m delta a by a. The power of m has to come here. For those, yes, so there is a question. Ashmeet says, why round off? There is a certain rule while you know, Ashmeet, that whenever you report any answer from laboratory, the answer should always signify the least count of the device that was used. That's the reason why whenever we report the answer, we do it in a rounding off pattern. So you may say that that's a standard protocol, how you report a value from laboratory. Let's make it short, sweet, simple, crispy. All right, Ashmeet? Now let's see here. The m will come here, and for those who have a mathematical background, I'll just give you an idea. The m comes because you take log both sides and you do the derivative, and that will give m as a coefficient. For those who are not into mathematical background, the news is much better. It's a formula. you multiply by that. So now m delta A by A plus n delta B by B plus P delta C by C. That's how it comes. And just recall, if it was multiplication, C would not be there, mn would be 1, so m is 1, n is 1. You come up with the exact pattern what was given in case of multiplication or division. And one thing more, if you get certain things like this that let me tell you, say for instance this was in percentage error, then this will by default come in percentage. So if these are the fractional error, the outcome is the fractional. If these are the relative error, that's the same thing. And if these are percentage error, this would also be a percentage error. That's how it comes. Let's see with the question. All right, guys. X equals to a square root c divided by b. So there is a quantity which is defined by x, and it is given that the percentage error in A, B and C are कितना देते हैं एक बार देखते हैं. A के लिए प्लस माइनस 1%, B के लिए प्लस माइनस let's say 1% again, और C के लिए plus minus 2% respectively. So that word needs to be added. So this is for A, this is for B, this is for C. Calculate percentage error in X. Please do that. You do not know. New Delhi is waiting for your answer. Yes. Aishwarya says 2%, Rakshit says 4%. Aishwarya, you have done a bit small error. It's A, C and B. Generally we write as A, B and C, and this was knowingly I gave, just to put on the subconscious. Okay, so let's see. Amal, Sakat, Tushar, Ashita, Yashwant, Shruti, Archismita, yes. So all are coming with the right answer. Benji again, Arvind, Pratik, Ashmit has come up with 3%. Let's see, Ashmit, the answer had to be 4%. Never mind. Let's see here. And it's something like this. Delta x by x will be plus minus, let me do directly, 2 delta A by A. So that will be 2 into plus minus 1% plus 1 by 2. All right, so let's say 1 by 2 delta C by C, and C is 2% here, so plus minus 2%, and B, the power is 1, so plus 1 delta B by B is 1%, so plus minus 1%, and that's certainly going to give us plus minus 4%. That's how it comes. All right, now one common mistake that may happen is that, as I said, because we are trained in our mind in that way, that's A, B and C, that's how it comes. So you need to be careful with this. There was a request from Vedant to explain the previous question again. Vedant, perhaps you're talking about the density part. I think I remember the data I had given impromptu, but let me be a bit faster, all right? 100.00 and volume was 10.00 cc. This was in gram. Vedant, nothing is said, so this will signify delta M as 0.01 and this will signify delta V as 0.01. And if you want, Vedant, the density first, density is mass per unit volume. So you calculate the value, that is 10.00, dividing mass by volume. Then what you get, Vedant, is delta rho by rho, because it's a division, delta M by M plus delta V by V. So you just plug in the respective value of delta M, M, delta V, V, and take this row this side, you multiply, you'll get 0.01. So Vedant, that must have made the things clear. Now let's go with another part of the error here. Now a small, do take care, because since you are not in the mathematical background, you haven't done the derivation. So, you know, you're just relying on the formula that I have given. So it becomes my duty that I just need to show those areas where you may be trapped. So that's very required. So it's something like this, say, some special case. For example, if I have, let's say, Z equals to twice of X plus thrice of Y, that means there is a coefficient involved. So in that case, people remember, delta Z will be 2 delta X plus 3 delta Y, and even here plus minus. So that's how it comes. In other words, when there is addition, subtraction, if the coefficient is there, you just keep it as it is. As I said, you are not in the mathematical background, so you may be trapped in this situation. So you need to be careful with all this thing. But in case of multiplication division, now you need to be careful. In case of multiplication division, say it says Z equals to a constant C X square by Y. In case of multiplication division, Z equals to C X square by Y. Now delta Z by Z, first of all, in multiplication division, you know what is involved directly is the relative error. So that remains same as it is, but this C will not come. So that will be plus minus 2 delta X by X plus delta Y by Y. As I said, in absence of your mathematical background, you may fall into trap. These are the sort of questions that you may get. So let's say, for an example, I have volume of a sphere which is 4 by 3 pi r cube. Let's go with an example here, and this is in the form of product. So this will be plus minus 3 delta r by r. That's how the situation will come. And this is straightforward as per the advice that was given there. And finally, one format is there. That format is very, very important. And that format comes something like this. You have a format of 1 by r as 1 by r1 plus 1 by r2. The resistance in parallel. As I said, these are the so-called trouble area. Why is it a trouble? It's not because of lack of your IQ. It is because you are not into that mathematics. So I have found lots of medical candidates just, doubting and suspecting on their ability, but they don't realize that it is insufficient information because you're not trained in maths. So it becomes my duty that I show you those areas where the examiner may trap you in the mathematical part. So you just take it, it's this. Delta r by r square would be plus minus delta r1 by r1 square plus delta r2 by r2 square. So this will be the underlying formula. in the case of resistance in parallel. So just be careful with this, okay? That is very much necessary. ठीक इसी किस्म का फॉर्मूला हमें ऑप्टिक्स में मिलती है. The optics case where you have a plane mirror or spherical mirror to be precise, or the lens. तो इस केस में you know that 1 by f is 1 by v plus minus 1 by u. Quantity would be done accordingly, like if it is lens, you would do 1 by v minus 1 by u. The quantity is done as it is. But when it comes for error, delta f by f square will be delta v by v square plus delta u by u square. So you need to understand this thing more precisely. If I write, that will be plus minus. So these are the other situations where you may trap quantity. Okay, there was a glitch. Let me see. Meanwhile, I've got the questions here, don't worry. I have also got questions from their Aishwarya, Y search square, Sri Krishna, same doubt, Aravind, square in denominator. I'll just explain it. Don't worry. I'll just show you a slight bit and we'll just talk about that. Now, it's something like this, guys. You see, what you really find is, first of all, I'm happy because if you said y square in the denominator, that means you have noted of that fact. Okay, so now let's see. First, see, the idea comes in this way. 1 by r, if you differentiate, because while we do the derivation, we do the differentiation because you haven't been shown the derivation, so that's how it goes. Differentiation of 1 by r with respect to r, that is minus 1 by r square dr. You remember that? So in fact, essentially what we do is that we differentiate this particular expression, or we differentiate this particular expression. So 1 by f will be 1 by f square or 1 by r square dr, and that dr would be equated to delta r. So this is the reason why this square has come, and that's quite encouraging that you have noted of that particular fact, and I suppose that thing must have cleared your doubt as well. So let me just go with the winding up what we did. You know, with this discussion we have completed the measurement part, and we saw that in measurement how do we use Vernier caliper, how do we use screw gauge. These are all the case so that we obtain smaller least count, and lesser is the least count, better it is. We saw how we calculate the least count, and then we saw that if a certain value is erroneous, which always is erroneous, then it's always better that we see how that error propagates. And we talked about error propagation, the error propagation in case of addition, the error propagation in case of subtraction, multiplication, division, and certain situations where a bit of exception would be lying. So charged up with all these things and little bit of your application mind, I'm pretty confident that you people are really going to rock the questions related to this. And tomorrow we'll be beginning up with the dimension, the application of dimension, and if time permits, we'll also go with the kinematics part. So you must do this, that's very recommended. But if you get time, then just try to have a look of dimension, so that tomorrow's one is again going to be a wonderful thing. So this is all from the physics part. And yes, obviously, thanks for giving a nice rating of my diagram, and many people had come with 10 plus. Thank you very much. So it's in fact building up nice confidence within me. Take care, people. Remain isolated, remain insulated. We'll meet tomorrow in a nice, healthy condition. Till then, bye-bye.